All right, guys, we're going to start into chapter 3. So we're going to jump way ahead into 3, 4, but that's just fine because all we had going up to it was solving some one-step equations, but we're going to replace the equation part with an inequality. So all the skills that you just proved on your test are going to become handy. So x is now greater than or equal to -8. Okay, so some things that we're going to point out, right? So here's 0, here's, let's say, -8. Since it can be equal to, that means it's going to be a solid point right here. And x is to be greater than, so we're going to work to the right because those numbers are greater. The next one, very similar in our warm-up progression here. If x is being divided by 5, we're going to multiply by 5 on both sides. So x is now less than 10. Okay, so here's 0, here's 10. Now this time, since it cannot be equal to, we're going to leave this open, and x is less than 10. So you can see these one-steppers, there's not too much work to them. So we're going to focus today on the next two type of problems. So I get I here, we're going to add 1. All right, so 2x is greater than or equal to -1, and then divide by 2, and we'll leave it just that way. All right, so where would I find -1/2 on the number line? Well, if that's 0 and that's -1, here's where I would find it. I'm going to make a solid point right here because it is equal to, it does count, and x is to be greater than, so we're going to shade that to the right. So just use that squiggly line just a little bit. All right, and then you're going to start on the next one. So that means something special must be going on here. So let's go ahead and jump into it. So we're going to subtract 5. -3x is less than -9. Oh, well, that looks okay. I'm going to divide by a -3. Divide by a -3? If I divide by a negative, I got to remember to change out my inequality. So that's the big thing. That's what that star was for. Okay, we're going to change that inequality because we're dividing, or if I were multiplying by a negative, I'd also have to flip-flop that inequality. Okay, so let's go ahead and throw this one on the number line. Here's 0. Let's call this 3. Open or closed? It can't be equal to, so it should be opened up. And x is to be greater than that, so that's going to be to the right. So that's what we're going to get into. We're going to recap all those things, but that was the most important thing right there. So I want to hit that right away. All right, so you're going to continue using your solving skills. We're going to add 5 to both sides. So 7a. I always change them to x's. That's okay. It equals 14, or it's less than 14. Divide by 7. X is less than 2. All right, so here's where you want to start to take over. So here's 2, open or closed. All right, it can't be equal to, so it has to be an open point. And if x is less than, then we're going to go to the left. All right, so can we also write the inequality? 1/3 of a number, 1/3 of a number decreased by 4 is greater than 2. I think we can do that. All right, so I just want to show where we're going to start to use some of these things in our number theory problems. So that adds up to 6. All right, now this 1/3 of a number, sometimes that gives us some trouble. But remember, what you want to do is multiply by its reciprocal if you're faced with a fraction. And since it's 3/1, we don't really need that part, right? So x is going to be greater than 18. All right, so I'm going to put my 0 over here. 18 is definitely somewhere way over here. Open or closed? Can't be equal to, so it's open. And greater than is shaded to the right. All right. Now, not everything's going to work out nicely. As I look at these numbers, I'm like, I don't know if that's going to divide by 11 very nicely eventually. So let's see what happens. So part of putting things on a number line is really just to think about where its location would be. If it were a decimal fraction, proper fraction, mixed number type of thing, divide by 11. So y is greater than or equal to. So I might make this, just because I have to put it on the number line, -1, because 11 goes into 14 one time, and then be 3 11ths left over. So that gives me a roundabout idea of where to put this number. So here's my 0, here's my -1, here's my -2. I want to stay closer to that -1 than my -2, because 3 11ths really isn't that much. All right, I have an equals to, so I'm going to make a solid point right there. And y is to be greater than. So if I want to have some fun, I might pick out some different colors to kind of shade that number line, but I just use the squiggly line. All right, let's see what else we can do here. Let's subtract 5. All right, so that's 10. Negative 8c. All right, now I'm seeing a negative 8 with my variable, so I'm starting to think that something's up. Right? Remember, there was something special I had to do. If I divide by negative 8, which is exactly what I need to do, c is now, it was opened up towards the c, so I want to open towards the number now. So I don't really bother with the whole greater than, less than. Well, I'm in this process part of it. Uh, I want to think about it. It's opening up, or some kids say it's pointing to the number. So now I want it to point to the variable. And 10 over 8, it's negative. So let's make it 5/4. Do I know where that is? Yeah, that's negative 1 and 1/4, right? Because it'll go in one time and left over. All right, so let's put that on the number line. 0, 1, 2. Negatives, of course. Open circle. All right, now this says C is less than. Okay, so less than is going to go this way. All right, so remember, some of you might be saying, but the arrow itself is pointing the other way, right? That's only if your variable is on the left. So if that was like a shortcut somebody taught you, you'd have to rewrite this whole thing. Okay, so it'd be C, and this is another place. If I go and solve this, but it's multiple choice on my standardized test here at the end of the year, and I have negative 1/4. And this is why I think about it as what it opens to or what it points at, right? It opens up towards the number, or it's pointing at the variable. So it opens up towards the number or it's pointing. Okay, so if I need to rearrange it, don't worry about calling it anything. Just look at it literally for the way it is, whether it's opening up or pointing at a number. All right, next one we're going to add 5. That seems like a good start, right? Because we're subtracting 5. That's the inverse property to solve. R is being divided by 8. This gave us, what about negative 7? All right, so let's go ahead and multiply by 8 to get rid of that 8. So R, and this would be 5, 6, 7, 8, 56, right? Oh boy, so if I put that on the number line. So here's my 0. Let's call this negative 56. Obviously not drawn to scale for 1, 1, 1, 1. I'm not going to put all those in. I just want to make sure that we get the idea that this should count. So I'm going to make it a solid point. R is less than, right? I'm reading it this way. R is less than. So we're going to go to the left from there. Again, if you need to rewrite it, R and negative 56, keep in mind that this thing is pointing at the R. Okay, so now it follows that shortcut maybe somebody taught you in middle school. You see a lot of the same, just trying to make sure that as we work through some of these problems, you catch when we need to, changing any inequalities. All right, so quickly we moved our 3 by subtracting. We're going to divide by negative 3, dividing by negative 3. So that means I want to change that inequality. It currently says less than. Now we're going to go greater than. 15 divided by 3 is 5, both negative, so it become positive. And we'll throw that on the number line as well. Open or closed? Closed it is. And we want to be greater than that. So there we go. And again, you know, when I find kids solving problems, sometimes just this fractional stuff. So I want to make sure I put enough in front of you so you feel pretty good about it. All right, so we're going to subtract 1 to get it to be negative 6 because it was already negative. We're going to multiply by what? 7. All right, so x is, do I change it? No, right? Because I multiplied by positive 7, so I didn't have to do anything. Negative 42 becomes part of my answer. 0, negative 42. All right, it's going to be open here, and we want to be greater than. So here we go to the greater side, or the right. All right, 4 more than the quotient of a number in 3. All right, so quotient means a division problem. Okay, so that means I'm going to divide a number in 3. But I need 4 more than that. Is at least that number. Let's see, is at least. Okay, so that means this would have to be greater than or equal to, is at least. Okay, so when we get into the word problems like this, something like this, is at least, it really seems backwards to the way you want to think about it, that you're going to use something called greater than for is at least, but that's the proper notation we want to use. All right, so it looks like we jumped up to variables on both sides. So, we have a little more thought-provoking question here that this is 1x. So if I subtract 1/3 x, how much do we have? Well, 1 minus 1/3 is going to be 2/3 x. All right, and how do I get rid of that? So this is a very challenging problem. Right? So a lot of us might think we're going to divide by 2/3, but remember that means we're going to multiply by 3/2. So I'm going to put my 4/1 as well. Okay, so this was kind of a tough problem to work through. So if you multiply through the top, so we get 12/2. Okay, so I might show 12/2, which is 6. And all of those things were positive. If you really like to rearrange it, we can flip-flop it. Remember, it opens up towards the 6. So either of those work. So we can put that on the number line as well. So here's 0, here's 6. I see an equals to, so it does count. We're going to fill that in. And x is to be less than that. So whoop, there it goes. All right, so that's what we're moving up to, is putting variables on both sides. I think you have the idea. Okay, I got a few more examples here. And the other one had decimals, so we'll skip over that. But remember, if this one is just all of it, right, all of this is stuck together in the top, or the other idea we just did proportions is you can figure on multiplying by 2, because that would have been one of our first steps anyway. So I have x plus 3 is less than 16, negative 16, and then subtract 3. So x is less than negative 19. So we throw that number line, just keeping in mind that since it just says less than, we're going to keep that an open circle. Okay, so we'll show you that one more time, and then we'll call it quits for this video. 3x minus 1, and again, we have less than 12, right, because it would have been this way as well. Okay, or if you're up to it and you're ready for it, we're just going to say we're going to multiply this by 6 and this by 6, because that's the same thing that happens when we cross multiply. All right, let's add the 1. So we got 3x is less than 13 divided by 3. All right, so that's all we really need. If you're going to put it on the number line, we probably do want to get at least a mixed number, if not a decimal. All right, so I think that covers it. Remember, the big thing today was open and close circles. But before that, anytime we are going to divide by a negative, we got to flip-flop that inequality.